This is case J, and it's one of my favorite because it involves directional data. Directional data is information that geologists and geological engineers use all the time, and they're already familiar with this kind of information, from taking strike and dip, looking at the orientation of discontinuities or streams or other linear features. And civil engineers often use this kind of information perhaps to a lesser degree, but we need to have a method of looking at the data and trying to decide whether or not there are preferred orientations. So we're going to look at a case involving 50 homing pigeons that were disoriented, and then the direction of their flight was observed. And we're going to apply a chi-square test to see if we have any observable preference in the directions in which the homing pigeons fly. So we need to use an appropriate hypothesis test, and we're asked here, it's suggested that we used 8 different categories to divide the quadrants into the compass directional data into, and used a level of significance. So if we try and prepare a hypothesis test, we'll say the null hypothesis is that all 8 classes equal against the alternative that not all are equal. And we're going to use an alpha of 5%. So with that, we'll begin. But this is real life information. Well, maybe not real life, because as I know, no animals were harmed in the preparation of this example problem. But this is the type of information that we'd get, and we'd have it's somewhat arbitrary. How do we define these classes? Should we start from 0 to 45 degrees, or should we go from use some other interval to define our categories, and have a category that's centered at 0 instead of having one that starts at 0? So when we divide up the different parts of the compass into 8 classes, we should make them all the same, and then if the null hypothesis is true, the number that we get in each one of those classes should be the same. Well, if you take 360 and divide it by 8, you'll be able to get the number that should be expected in each one of the classes. But here's the actual data. Whoops. Here's the actual data. So I had an earlier attempt here. I should have erased. Sorry about that. So here's the directional data, and we need to categorize it into whatever intervals we choose in order to decide how to work this. Well, I went with 0 to 45, 45 to 90, etc. And then I can get the number that I expect in each one of those 8 classes simply by taking 8 divided 50 divided by 8. So that's how I got the number expected. That's 6.25. Remember that I needed to have at least 5 or more expected in every category, and I have that assured. So I'm able to divide this up, and because I have only whole numbers in my directions, I went with a directional class of 0 to 44, 45 to 89, etc. And then I could look through my data and count the number observed in each category, compare that to the number expected in each category. I calculate my chi-squared statistic, and again, we're familiar with that chi-squared. The formula for my chi-squared my pen is not working right. My chi-squared is equal to the number observed minus the number expected, and then I square it, and then I divide that by the number expected in each category, and I calculated that here and summed that up, and I get a total of 1.84. But now what I need to do is calculate what my chi-squared critical is, and so I'm using a chi-squared critical can be found using an alpha of 5% and the number of degrees of freedom equal to, I use the 8 categories, so I need to go with 7 degrees of freedom. So once I have that, I can go back and look at my tables to find what is the chi-squared for this case. And this is that table, and if I enlarge it just a bit, I can find the number of degrees of freedom is 7, and alpha is 5%, so I want the 0.95 case, which means that I have a critical value of 14.07. So, going back to my problem, oops, I forgot what my critical value was, sorry. What did I get? I got, oops, wrong table. Here's the right table. I got 14.07 for my critical value of chi-squared. My degrees of freedom is 7, 8 categories minus 1. So 14.07. Zoom back out. The critical value was 14.07, as our chi-squared is less than chi-squared crit, because 1.84 is indeed less than 14.07, we have no reason to reject the null hypothesis. So we really do believe that the homing pigeons have no preferred orientation in their flight after disorientation. And that's the end of case J.